Actually, if code cache size is something that is interesting to you, well, there is an application that we can use to monitor the code cache usage over time. And this is particularly useful if your application is running on a remote server somewhere, but you want to monitor it from your computer. This comes as part of the JDK. It's an application called JConsole, and well, let's open it up and have a quick look at it. So you'll find this in wherever the JDK is installed on your computer. If you're using Windows, that's probably under Program Files and then Java. And we'll navigate into the JDK folder. I'm going to use JDK 11 here, and then into the bin folder. And there should be an application in here called JConsole. So here it is, JConsole. We can just double click on it to run it. And we're asked which of the processes do we want to connect to, a local process or a remote process. We'll just use the local process in our example, and well, what we should be seeing here is a table of all local Java processes. Now I've got the Eclipse application running in the background. Eclipse is a Java process, so I should see something in this table here. If you're using Windows like me, you might not. If you're using Mac or a Linux, you almost certainly won't have this problem. But if you're using Windows, there is something you need to do to make this work. When Java applications run, they store their data in a particular folder, and it's this folder that's being monitored by JConsole to find out what is the process ID of a running Java application. But unfortunately, sometimes, and in this case it's happened, that folder isn't writable. So we need to do something to make this work. So to go to the folder, you need to go to, and it will be wherever your users folder is, then your username, app data, local, and then temp. So a folder structure that looks like this. And within that temp folder, you should see a folder called hsperfdata_. So I'm just going to scroll down here, and there it is. And at the end of that will be your username again. And it's this folder that needs to be writable in order for the JConsole to work. So we need to right click on this folder, choose Properties, then go to Security, and under Everyone, choose Edit. And we want to make sure that everyone can write to this folder. So we need to at least tick Modify. I think I'm going to give everyone full control. I don't think there's any reason not to do that. We'll click on Apply and OK. We'll then need to restart any applications that are running Java. So I'm actually just going to go into this folder, which is empty at the moment, and I'm going to exit Eclipse and restart Eclipse. And Eclipse is just starting up now, and we can see that something has been put into this folder, so that's great. That means that that is now running, which means that if we go to our JConsole, and I'm just going to wait a moment for Eclipse to start. It has started there in the background, and I can close this window and try that again. Click on Connection and New Connection, and now we can see that there is a PID or a process ID there, which is the Eclipse process. So we can connect to Eclipse, and we'll just need to click on Allow Access here for firewall issues. You need to choose Insecure Connection. It takes a moment, and there's various things in here that we can see. Actually, there are other tools we'll be using later to see some of this information in a bit more of a useful way. But while we're here, if we click on the Memory tab and then change this chart to say Code Cache, that will show us the size of the used code cache over time. So actually we can see down here that the code cache is allowed to grow to, I think that's 240 megabytes, which is the maximum. And at the moment it's around about 26 megabytes. And you can see it is slowly growing over time as Eclipse is doing things in the background. I'd quite like to connect to the application that we've written to see that code cache time. One of the problems in doing that is that the application has to run long enough so that we can connect to it. And of course, our application ends very quickly. So what I think we'll need to do is make it work for a bit longer to give us time to connect. And well, the way we'll do that is let's add in a thread.sleep and tell our application to sleep for 20 seconds. That's 20,000 milliseconds. That should give us long enough to be able to see what's going on. I think we'll then put in a print line to say starting the work. So we know that the real work is now starting. We'll need to put either a try catch block or a throws declaration in to handle the interrupted exception for thread.sleep. I think we'll just add it as a throws declaration. And then let's just save this. That looks like it's going to compile, which means, and I think we'll run this from the command line again. So I'm going to do here, it's Java main 5000 to say 5000 prime numbers. And let me just move that window up there so we can see the top bit, while down here we want to do a new connection. There's our main 5000 we want to connect to. And we'll go to the memory tab and choose code cache size. So it's currently on, actually it's much bigger, and we'll understand why that's the case in a moment. It's bigger than it was before, but now, well, actually our application has done the work and it's finished and nothing particularly has happened there to the code cache size. And in fact, of course, we're told that we have lost access to our application. So why was the code cache size so much bigger there? Well, actually, that's one of the slight issues in doing this kind of remote connection. And the answer will become clear if we use the print compilation flag. If I run this with Java -xx : print compilation, and so I'm going to start this running now, and not much is happening before we start work, but now let's do that connection. So we want to do a new connection to our main 5000, and wow, you probably saw there a huge amount of compilation going on in the background, and in fact our application hasn't started doing the work yet. There's still lots of compilation going on, and there, the application started doing the work just a few seconds ago. So unfortunately, using JConsole to communicate with the Java virtual machine, what happens is that the virtual machine is doing some extra work to do that communication, to provide the information that JConsole needs for it to be able to display its various charts. And unfortunately, all of that extra code that's built into the Java virtual machine, well, some of that, as we can see, has been compiled as well at different levels of compilation. And that's what's changed the in-use size of our code cache. So the lesson here is that if you want to use JConsole to monitor the size of the code cache, you absolutely can do that, but it will use an extra roughly 2 megabytes of the code cache to do that. So if you see your code cache growing when you're using JConsole, that's still valid. Just bear in mind about 2 meg of the used code cache is simply used in order for JConsole to connect to the running Java virtual machine. So that's the starting point then for what the Java virtual machine does at runtime, how it compiles part of your code to native machine code and stores that compiled code if it reaches level 4 in a special part of its memory. But that's not the complete story. In the next chapter, we'll see more of how we can use this information to optimize the performance of our applications at runtime.